Number 3. So here we're looking for the tensions in the two wires. Let's go ahead and draw a free body diagram. And there's going to be a force here, that tension here, and tension over here. Now, this apparatus here is going to have a weight in the center because it's a uniform. And then we have another weight here, which is going to push down with a force here equal to its weight as well. So these are all the forces. Let's go ahead and label them F1, F2, F3, and F4. And we are looking for F1 and F4. So we can pick the pivot point at one of these two wires. So I'll go ahead and pick it here. And this will allow us to solve for F1. So we need to go ahead and define our distances. So R1 is going to be 3.5 meters. R2 from the pivot to the weight is a 2 meters here. So this distance here is R2. It's 2 meters. And then R3 is going to be half of 3.5 because the weight was at the center. So it's going to be 1.75 meters. And then let's go ahead and define our forces as well. F1 is what we're looking for. F2 is the weight, which is 550 newtons. And F3 is the weight of the apparatus, which is 1200 newtons. So here, since we don't just have one force on each side of the pivot point, I'll go ahead and sum up all the torques equal to 0. No shortcuts here. So F1 is going to produce a clockwise torque. It's going to make the stick rotate like this. So it's going to be a negative torque, negative F1 R1. F2 is going to cause a counterclockwise torque, so a positive F2 R2. And F3 will also cause a counterclockwise torque, F3 R3. And all of these will equal to 0. Again, F4 does not produce any torque because it's at the pivot point, so the distance R4 would be 0. And then now we can solve for F1. It's going to be F2 R2 plus F3 R3 divided by R1. And that should be 910 newtons. Now to find F4, we could do this again and set the pivot point over here and go through this whole process again. Or what we can do now is use another condition of static equilibrium, which is that the sum of the forces in the y direction must equal 0 since this object is not moving. So this means that F1 plus F4, they're upward, so they're positive, minus F2 minus F3, all of those forces must equal 0. So this is a faster way to solve for F4. F4 will be equal to F2 plus F3 minus F1. And that should give us 840 newtons. Number 4. So we're looking for this mass over here, but we don't know the masses over here. So we're going to have to do this in a few steps. We can start here with the smallest part of the mobile here. So we know that the weight here is going to produce a torque that must balance the torque over here, right? This one is going to produce clockwise torque. This one here is going to produce a counterclockwise torque. So the two torques must balance. So the torques are due to the weights. So if I'm just looking over here, what I would have is I would have 5, which is the mass, right? 5 grams is the mass, and times G to make it equal the weight. That's the weight here. Again, I'm leaving everything in grams because the final answer is in grams, so no need to convert everything to kilograms. So this weight times this distance, which is 4, I'll leave it in centimeters because everything is in centimeters. This torque will balance the torque on this side, which is x grams times G, and a distance of 2. So we can see that the G cancels out. So to find this amount of grams here, x is just going to be 20 divided by 2, which is 10 grams. So this one here will be 10 grams. And now we do the same thing over here. So over here there's going to be a torque, and it's going to be balanced by the torque over here. So on this side, the weight on this side is the sum of these two. So 15 grams times G. And I'm just going to leave out the G because we see that it cancels out. So 15 is what's producing the weight here. The distance is 1. That's going to be balanced by over here, whatever this mass is. And this distance is 5. So we can see that this mass over here is going to be 15 divided by 5, which is 3 grams over here. And then we do this one more time. We have the weight over here is going to make this go clockwise, and the weight over here is going to make it go counterclockwise, so we balance these torques. So over here the total weight is going to be 3 plus 10 plus 5 is going to be 18 grams. The distance is 8. That's going to be balanced by the weight over here, which is called m this time, and the distance here is 4. So we can see this time that m equals 18 times 8 divided by 4, and this is equal to 36 grams.